Hello. Today we're going to be talking about optimizing a right circular cylinder, which will be inscribed into a cone. Now this cone is going to have the dimensions of a height of h and a radius of r. And one of the difficulties with optimization type problems is drawing the picture and correctly labeling your variables that will ultimately be the equation for the volume of this cylinder that I want to optimize. Again, I want to find the largest possible volume for this cylinder. Now, in order to do that, I need a volume equation. This requires me to draw a picture so I can identify my variables correctly. Now, a cone looks like the following. And we are inscribing a cylinder inside of this cone. So that is the cone, or the cylinder is inside this cone. Now, the volume of a cylinder is equal to pi r squared times h. But we are given that the height of the cone is h, and the radius of the cone is r. So these variables are not going to make much sense when I'm trying to optimize, since I'm already dealing with h and r. So instead, I'm going to label the radius of this cylinder as x. That's going to be a radius of x. So my new equation is going to be pi x squared. Now, I want to find a height of the cylinder with respect to the cone, since it's confined inside this cone. One way we can do this is I'm going to first label the height from the top of the cylinder to the top of the cone. I'm going to call that y. Now, as a consequence of that, that leads me to make this height h minus whatever that height y is. So I'll say h minus y. And so that means instead of h, it's going to be h minus y. And so this gives me the equation for the volume of the cylinder inscribed inside of the cone. Now that I have this drawing, I can now maximize this equation. Now let's look at this. We have just constructed a triangle. So we have here a triangle. Okay. And so from this triangle, I have this length here of x. So I'm going to call this a length of x. We have this as the radius of the cylinder, which we already know that to be r. We know the height of this is h from the height of the cylinder. And so then that leads me to this length, which we called y. And what we should see here is we have two triangles. We have one triangle that is h by r, and we have another triangle that is y by x. These two triangles are similar. Since we have two similar triangles, we know by that property y over x is the same as h over r. That is, they are both proportional. Now, if we look at the volume equation, the second one that we found based off of our drawing, we know that we need to rewrite this volume equation in terms of only one variable. We have it as x and y. And again, h is a fixed number. It is not a variable. So I could solve for y in this ratio, which would give me y equals hx over r. And so we will need this property, we will need this y value in order to complete this optimization type problem.